Oh, there we go. Hi. This video is about the loudness or softness of sound waves. Did I get you with that one? So let's talk about intensity of sound waves. So I've got my tuning fork here, and if I hit the tuning fork, it starts pushing air molecules around it. Now, if it's hit harder, oh, that wasn't harder, I missed. It will actually move back and forth at a greater amplitude. So it'll have more energy to push with. And that's because if a vibrating source of sound waves has a high amplitude, it can displace air molecules further from equilibrium, which means you're doing more work on the air molecules. You're creating a wave with more energy. So low energy waves would have a small amplitude of displacement for the medium, but high energy would mean there's a high displacement for the medium. And this high energy is also known as high intensity. The amount of energy that's transported across a given area through space per unit of time is known as intensity. And intensity diminishes exponentially as you move further and further away from a source of sound. It follows the inverse square law. So as you get further and further away, the intensity of sound gets lesser and lesser exponentially. So let's look at one way that intensity is measured. And you may be familiar or have heard of this before. Because humans can actually hear a very wide range of intensities for sound waves, we measure the intensity of sound on a logarithmic scale, which is basically a powers of 10 scale. So we call this scale the Decibel Scale. And what it really means, I'm not too concerned about the mathematics behind the scale here, but what it essentially means is if you start at 0 decibels and you go up to 10 decibels is 10 times greater than 0 decibels. If you go up to 20 decibels, now you're at 10 to the second power. And so that's 10 times 10 is 100 times greater. If you go up to 30 decibels, that's 10 to the third power greater. So that's 10 times 10 times 10, that's 1,000 times, and 10,000 and 100,000 and so on. So we're making big steps forward in intensity levels, but that's just because our ears are built to hear just a wide range of intensities. And so it doesn't sound necessarily like it's 1,000 times louder, but that's mathematically speaking, energy speaking, it is. So you can kind of see here some of the levels of sound. We have soft noises from 0 to 40 decibels, things like, leaves rustling, is 20 decibels. Normal kinds of sounds like moderate sound waves are going to be 50 or 60 decibels, around that range. So like this video hopefully is at that kind of level. Normal conversation, 60 decibel level. As you get into 70 and 80, it starts to get loud. And so that's things like a vacuum cleaner, a police siren, going to a noisy restaurant would be in this level, where it might be hard to hear somebody else talking over this thing. Then if you keep on going here to like 90, 100, 110, it starts to get very loud. And if you're exposed to this kind of intensity of sound for, a long period, like think 30 minutes, hour, like long period exposure to this kind of intense sound, it can be harmful to your ears. Things like a hairdryer or a motorcycle or a sports crowd, like getting really loud for a minute there. Those are very loud sound waves. And then even higher than that, we get up to 120, 130. We could keep going. Things like a concert or fireworks, these things are painfully loud at times, and they can be dangerous to your hearing. And so you have to be careful about long exposure to these kinds of things. But anyway, that's how we kind of measure intensity of sound and what makes something louder or softer. And that's all I've got for you in this video. Remember, humility is not thinking less of yourself, it's thinking of yourself less.